everyone, welcome to Duodecimal Division. My name is Eric Larson and this is the fourth video in a series of videos that I'm calling The Secrets of the Numerals, in which I'm sharing with you how someone in our past used this particular geometric pattern to come up with the various designs of the various numerals. So in this video we're going to look at the fourth ring, or go to the fourth ring in this pattern, and see if we can figure out how someone came up with the design that looks like the numeral that we call the 4. So we're going to go, like I say, to the fourth ring, and we're going to go to the points again, the lattice points that define where the radius of the circle is sitting on the grid. So there's 4 of them for this particular ring. So we're going to go 1, 2, 3, 4 right here. Put a point there. I mean, you might not, obviously you can't see, I haven't drawn in the other lines here, but these are lattice points. You know, there's a horizontal and vertical line there, so there's going to be one there. And I'm going to go down to this one here. So we're just going to use 2 of the 4 lattice points, and then I'm going to draw a line that connects the 2 of them just like this, straight up the middle. And right away we have a line that has the length of 4. And that's one of the characteristics that all of these numerals have. They all contain the value of the number that they represent. So there is our line with the length of 4. Then what I'm going to do is follow the circle around until it intersects with this point here, which is the -1 y coordinate. And I'm going to draw a line from there up to this point here. I'm going to see if I can do it with freehand. Something like that. There we go. We can see how it's intersecting a lot of the points along the way here. That one there, and that one there, and this one here and there. It's also cutting down. There's a lot of points that line is going through, so it's quite a, again, important geometric line in this design. So now what I'm going to do is draw a line along the bottom here and just go along to this point right here, where this diagonal or degree line is intersecting also, again, the negative y coordinate. So that's basically it right there. Now you have the numeral that represents the number 4. So what we're going to do now is just go over all the lengths that are incorporated within the symbol and how those lines have also been divided up. So we've got, for starting, the length of 4. Write that down here. And then we also have the length of 3. So we put that there. And I guess you can see already, I'm just going to grab special right angle triangle. Okay, here we are. So I was just going to say, you can see, I hope, that is the same proportions. Let's see if I can pull it out and just do it like that. You can see it how that perfectly that fits right in there. Basically, again, special right angle triangle. We've got that triangle right in here. And in terms of secrets of the numerals, this is a secret that's basically been in plain sight the whole time. So this numeral obviously contains, or is made up mostly of, the special right angle triangle. So if that's the case, here we have the length of 3. I'll just draw that triangle right here. We know its proportions are 1, 2, and the square root of 3. So because this length we now see is 3, we're basically multiplying all these sides by the square root of 3. So we can see right away that this length here is the length of the square root of 3, which we can also see by just going up straight up here, and there's the square root of 3 radius circle. So this point here is right below that. So again, very easy to figure out that this length is the length of the square root of 3. But before I write that, let's just figure out what that total length is, because we still have a pattern here. We're going 4, then 3. I think we can see that this length here is the length of 2, because we've got this little extra tail here. And this length here is the same as this length here. Basically, it's the length of square root of 4 minus the square root of 3. So this gap there, that's the gap between the 2 rings of this geometric pattern. And this is the same here. So we have the length of 4 and 3, and then 2, and then also 1, the length of 1 right here. So those are those 4 parts. And then again, the length of square root of 3. And then we have the length of this length here, which is 2 times square root of 3. And again, I'm going to write underneath that is the square root of 10, because we're in duodecimal. That was the diameter, basically, of the last symbol for the square root of 3, or the number 3, or the numeral that represents the number 3. The diameter of the circle with the radius of square root of 3. That length right there. And then this little section here is 2 minus the square root of 3, which again is also be written as the square root of 4 minus the square root of 3. So that's all the different components of this triangle, or this numeral. And so again, lots of geometric information encoded within that design, some very pretty obvious in a sense, and very common, familiar geometry there. And you can see how many hidden triangles are in this pattern, and how many other variations and angles are all encoded within that symbol. That's why the numeral 4 looks the way that it does. So this particular numeral doesn't have any curves in it, obviously. It's just straight lines, and in a way it's kind of a summing up of the patterns so far. You know, the 1 and the 2 and the 3 all had parts of circles in them, and actually there's a little pattern even in their progression. You know, that first, you know, here it is right here, the 1 was like this, and it has this part of the circle is 1/6 of the whole circle. So I'm just going to write that down here, because it's kind of a, like I say, we're sort of summing up where we are so far. And that was how much circle was in that pattern. Then the 2 was up here, and it kind of went across like this, and that was a quarter of the entire circle. So I'm going to put that here, a quarter. And then the 3 basically started here, and it went all the way around like this. I know I'm kind of messing up my drawing, but that was a half of the circle. So it's an interesting progression of half, a quarter, and a 6, or 6, a quarter, and a half. And if you were even to sort of give all of those circles the diameter of 1, say, then pi would be, you know, it would be like a third of pi, a half of pi, and then just, you know, basically 1 pi in terms of the lengths of that's being covered by the circle, of the circumference of the circle. Okay, getting a little off track there, but that's the 4. That's all the pattern that's been, you know, kind of encapsulated within the circles and the lines and the numerals up to this point. It's just the line is sort of saying, here we are, square root of 4 is 2. Everything works out evenly on this particular symbol, and the lattice points and the grid and everything. So basically that's it for the numeral 4. So the next numeral is the numeral that represents the number 5. That's the next video. We're going to go to the 5th circle in the series for that. So I hope you've enjoyed this presentation, and you can join me for the next one. Thanks for watching.